depends on the arteries. Like how many are blocked.
They're plugged up. I had bypass means it was just one part. I just tried to point out 1, 2, 3, 4. So that means in one of these branchings that occurs, that artery was blocked. And if it was blocked, what do you think that's doing to the heart muscle of that area? It's not. And I have just had a myocardial infarction.
Oxygen supply stops.
Everything stops.
Why is that?
Most of the time, usually cholesterol buildup, hardening of the arteries. Most of the time, it's usually a defect in that artery that has occurred. It could sometimes be an anomaly, meaning they don't know. It could sometimes be related to your diet, meaning most likely buildup of like the cholesterol. Okay. Sometimes it could be something that's genetic. So there's different things that can actually contribute to it. If I had a double, 2 areas. If I had a triple, 3. If I had quadruple, 4. So when they do the bypass, what they have done is they have gone to these areas that have been clogged and they reroute the blood flow.
Can there only be up to 4 for like bypass, or can it be a
I think it's very unusual to have more than that. People usually don't survive more than that.
I had a resident at my job. He had a couple bypass.
He had a 5, okay, and he survived.
Yeah.
Okay, okay. A double bypass? Yeah. You usually hear it in relationship to bypass, double, triple, quadruple. And this is kind of letting you know what they're telling you. And what they've done, because the way that the heart muscle will work, the heart muscle will, because it is one cell doing its job, if this group of cells dies, you can actually reroute, meaning the heart attack, okay? You can reroute the blood flow to the other cells in that area to give it more support. That's what the bypass does, okay? So this structure that is created by these blood vessels in the coronary circulation, based on where they're going to be found, which ones may have gotten blockages and so forth, usually determines the severity of that myocardial infarction. Okay, so these branches, all right, you may hear them talk about, you know, the left coronary or the right coronary. You may see that term in somebody's charts. So we can see that based on this information, the way that they are going to supply, all right, determines which part of the heart can be affected. Now, one of the things for us to definitely note about the supply, the right coronary artery supplying that right atrium. In that right atrium, we are going to have our SA node. Does anybody know what that is? Sinoatrial node. It is the pacemaker of the heart. We're going to come back to it. one of the things that you're going to find is that the heart is innervated, meaning there are nerves present. However, the heart is not dependent on the nervous system to function. The heart is not dependent on the nervous system to function. It is dependent on this SA node firing. That is why they call the SA node the pacemaker of the heart. It sets the rhythm. Even though the heart is innervated, it will affect the heart, meaning it can increase or decrease the heart rate, increase, decrease, or affect the pressures. But in the grand scheme of things, the heart is strictly dependent upon the SA node. When the heart beats, for every heartbeat, about 250 milliliters of the fluid goes to this circulation. So about 1/4, about 5%, about 5 to 10% of the volume of the heart every time the heart beats, it goes strictly to my coronary circulation, because this is a muscle that never stops, and it cannot do or survive on anaerobic fermentation. It has to have oxygen. If it doesn't, those cells stop. You have the MI, you either survive or you don't. So quite a bit of the actual blood flow, the blood volume in the heart, is going to this circulation, bringing the oxygen and nutrients. These are cells that have to have nutrients, and they have huge mitochondria, and they have a bunch of mitochondria in one little heart cell. It's amazing to me. When do you think the flow through the coronary circulation is the greatest? When the heart contracts or relaxes?
Relaxes.
Why?
Because when you're contracting, you're pushing it, but then when you're relaxing, you're allowing it to all come back in.
When the heart relaxes, if you go back to our picture, those two little spots, if you think of it being contracted, you have actually blocked those arteries right there. So when the heart relaxes, those arteries are now open. And if they are open, you're going to get that blood flow into the coronary circulation. you're going to get that arterial flow into this, into these arteries. And that becomes important to the movement of the blood. People can have stents put in, if you've ever heard of that, okay? People can go and have them cleaned out. They can, have you ever known someone who had like the, oh shoot, what is it called? They used to go through the leg, but now they go through the upper arm. Angioplasty, I think. And that's what they're doing. In that, they are checking the blood flow. The actual, and have you ever heard of people who maybe have to get,
It was an angiogram.
Angiogram? Angio something, angiogram, angioplasty.
Because they go in, we had a,
I remember.
I thought they did an angiogram on the check, like the fluid, it was like foot.
The inject with contrast and do it under radiology.
Under the yeah.
Whatever, see, whatever.
Yeah, and it used to be they had to go through like the femoral vein and had to go all the way up. But now I think they choose to go through one of the, up through the brachial.
Sometimes. They either go, they do stuff like in the wrist, sometimes they go through the neck, or they go through the femoral.
Ugh. I'm dreading having to get that done. And the reason I say dreading getting to have it done because I know I'm getting older. And I'm like, I'm just probably gonna happen. So I'm like, just wait for it, pretty much. But one of the other things that has become very interesting is how they can, do the echograms, the echocardiograms on the heart, and what they're seeing is the actual blood flow through the AV valves, which is really cool, I think. So this coronary circulation, all right, we start out at that area of those aortic semilunars, and we branch left to right, and we feed 4 sides, okay? And another part about it is the feed to the sinoatrial node. Now for return of the coronary circulation. Because these are cells that are active, they've gotten the blood flow, they have their cells that are extremely active, meaning they're producing waste. If they've got the huge mitochondria, well, one of the things they're definitely doing is the CO2, and they're using materials, so they're creating waste in other way. So we have to make sure that there's the ability to pick that up by way of the veins and bring it back to the heart and start all over again. So we have our coronary venous drainage. I tried to point out in the video, as well as to the back here, the area for that little bump that exists, okay? And it's called a coronary sinus. If you think about a sinus is like this huge hole, right? In the atria, you're going to see that by having the veins, and note, they've kind of given them terms of great, middle, small, okay? Great, middle, small. Once again, how many ways do you kind of notice? How many? 1, 2, 3, 4s? 4. So once again, pretty much running along with the arteries, so to speak. So their goal from great, middle, and small, return to the area of my coronary sinus. Guess where the coronary sinus is going to empty into? My right atrium. So the blood flow from the heart is going to drain back to the right atrium.